Hello everyone, my name is Roy Sasson. I'm the Chief Data Scientist at Outbrain. Thank you for coming for this lecture. I'm going to present to you a mutual work of Ram Meshulam and myself. It is about the difference between content popularity and content shareability, and how you can utilize that information in order to make better predictions to users. But first, I'd like to introduce you to Dee. Dee is a front-end team lead at Outbrain. And much like many of you, Dee likes to read content online. Every day, he goes to the homepages of his favorite publishers, he selects a few articles, he goes and he visits those pages and reads those articles. Based on what visits Dee has, we can generate a profile of Dee's interests, what he likes to read about. So for example, we can see that Dee likes to read content about mobile and basketball and celebrities and investing and television and movies. And the distribution here basically marks the proportion of what content he likes to read at what proportion. And of course, it's all encrypted, so I don't actually know that this is Dee. Now let me ask you a question. Suppose I would have been able to look at everything that Dee shares on Facebook and would have constructed a profile based on those shares. Do you think that shares profile would have matched the content-based profile? Probably not, right? Luckily, I can ask, since Dee sits in the office next to me, I can ask to have his user account on Facebook and start looking at what he posts on his wall. So he posts on Facebook basketball and content about television and movies and investment and careers and stuff about mobile. Let's go back to the visits-based profile that we can construct on Dee. Does it match what we've seen on Facebook? So we see that there is some linkage between what we see that he shares and what we see that he reads online. He shares stuff about mobile, basketball, investing, but something is missing, celebrities. We didn't see anything from his shares that relates to celebrities. Why is that? That led us to the thought of, do you share everything that you read? Not very likely, right? You don't even share most categories that you read. So we wanted to investigate that. What is the difference between what people share online and what they read online? If there is a gap on that, and we can utilize and understand that gap better, then perhaps that means we can make better content recommendations to the user. So luckily, Ram and myself work at Outbrain, and we have a lot of data to examine this question. So for those of you who don't know Outbrain, Outbrain is the largest content discovery platform. And the content discovery is basically when you read those articles on CNN and Fox and ESPN, at the bottom of articles, you see those additional links to other personalized recommendations that you might find interesting on the same publisher. That is what we do in Outbrain. We serve over 200 billion content recommendations like this every month. Those content recommendations are personalized recommendations to the user. There are two types of recommendations that we serve. One is what is referred to as Outbrain Engage or organic recommendations. These are content recommendations that the user would find interesting on the same publisher. And our business model is based on we give those recommendations, the engine, for free to the publishers, but we make money from making additional content recommendations that marketers and brands want the users to enter their pages. And I'm not marking them here because the focus of this research was about organic recommendations. To give you some grasp of how many users we reach every month, our distribution publishers, partners are among the largest publishers and most distinguished publishers today. They range from CNN in Israel to Ynet, Fox News, ESPN, Time, Washington Post, and all of these give us a reach of over 560 million users every month, which is quite a lot. For the sake of this research, we only used 1.8 billion data points, which is relatively small in terms of what Outbrain utilized. We wanted, again, to see the difference between popularity and shareability. We took 1 week of data, which gave us about 50,000 articles. They range across 200 different publishers worldwide that gave about 800 million page views, and for which those articles accounted for almost 50 million shares. For every article, we looked at the page views that article received, and when I'm talking about page views, I'm referring to entries to the page from the homepage of the publisher. So a user enters the homepage, clicks on something, they go to the article. We've also connected to the Facebook API and measured the share rate of every URL of every article. So that is data that you can easily access. And finally, we measured the click-through rate on the Outbrain widget for every article. These were the 3 metrics that we focused on. The first thing that we saw was that page views, the rank or the relative page views that an article receives, is entirely uncorrelated to share rates. There's no relationship between those two. The second thing was that we've seen that there's no relationship between what people click on the Outbrain widget and what people share. On the other hand, when you look at the correlation between CTR and page views, there is some correlation. It is far from perfect, but it is still positive. It's not 0. That led us to believe that perhaps if we can identify what is that difference between what shares encapsulate and CTR and popularity encapsulate, we might be able to serve users with better content recommendations if we combine them. Of course, there is also the alternative that each one of these metrics suffers from different biases, and this is why they are uncorrelated. Either way, all of that led us to believe that we should incorporate both metrics and see which one of them is more important in order to rank what user may find interesting. Before we did that, so I showed you one sporadic example from this profile that there is a difference between what people, where n equals 1, what people share and what they click on. We wanted to show whether we can actually show it with a large scale of data, that there is a substantial dissonance between what people do on social networks and what they read in the privacy of their own computer. So we defined something which is referred to as the private versus social dissonance. It is the ratio between the CTR that an article gets on the Outbrain widget and the share rate that that article receives. And the R that you see outside of the parentheses basically standardizes each article in relation to its publisher, because some publishers have, on average, higher share rates, some have lower, some have higher CTR rates, and so on. So everything that you see here allowed us to do it across 200 publishers into one metric that combines everything into one number. And we do the log for that in order to deal with outliers. So we wanted to see whether for the human eye, it can be very apparent about what is that difference between what people share and what people read. So we took all the categories, all the content categories that we have of articles, and we've calculated that dissonance for every article, and we've summed that up, we've averaged it across all the entire network, grouped by category. What you see here is the categories, the content categories sorted from left to right, where on the left you have those categories with a positive dissonance. That means that they have relatively high CTR, but nobody shares them. And on the right you see what the content categories that don't have that dissonance. They have the opposite. People share them quite a lot, but they don't read them quite a lot. And to our surprise, to the human eye, it's very clear what's going on there, right? What do people read but don't like to share with their 1,000 closest friends? Content about adults and sex and crimes and celebrities and fashion and relationships. So that's not very surprising, but once you see it crunched based on 1.8 billion data points, that makes something very clear. And if you see what people like to brag about that they're reading, then you see that it's music and careers and arts and books and wine, of course, and education. And D is set right in the middle there, right? So there are two personas for every reader. There is the persona of what they like to read in their own privacy of their own computer, and there is that persona that they like to exhibit. Still, when you combine it with the fact that there is no relationship between, there's no correlation between those two metrics, still gave us the suspicion that we might want to utilize both metrics. At least now, it was very clear to us that there is a difference between those two based on a lot of data. All the results that I'm reporting here were replicated on 2 different weeks. So we saw that on 1.8 billion data points on January 2015, and we replicated those results on November 2015, same ranking. This is something which is very robust that you see online. So finally we said, okay, so you have different engagement metrics, they're not correlated, everything captures something different. Maybe we can utilize that in order to improve our recommendation system. So learning to rank. The use case in which we utilize that is something which is called Sphere. Sphere is an Outbrain developed API that allows application developers to integrate and to inject content recommendations from Outbrain's recommendation engine into their applications. So the context in which Sphere's recommendations appear varies from Chrome new tabs to email applications to lock screen application, a lot of different contexts in which users see that. So everything that I'm going to report here is quite robust. It's not only limited to the results that you see down at those Outbrain widgets that you see at the bottom of article pages. So we had to estimate some model, to train some model that learns from CTR and learns from Facebook shares and learns from other things. So this is what we were trying to do. On Sphere, we tried to train a model that predicts whether a user would click or not click on a content recommendation. It was a function of several groups of variables. The first was article yields, everything that I'm talking so far. It was page views that the article received, engaged CTR, those CTRs that on the Outbrain widget, and the Facebook referral rates. Now note that I'm talking about Facebook referral rates here and not Facebook shares. The reason that we've applied here, and put a comma here, this is a small tip for all of you, we didn't have access to the Facebook API in real time to learn in real time which content receives higher Facebook shares and which one doesn't. What we do know is which content receives referrals from Facebook, because we see the users in real time on the publisher. So if a user saw a link on Facebook, clicked on it, entered CNN, I know that in real time. But if a different user has shared that link, I don't know that. So we use Facebook referrals as a proxy for Facebook shares, but the good news is that we do have data on some articles about the Facebook share rates, and you see that the correlation is very high. It's about 0.82. So if you don't have the access to Facebook API, or if you can't use it in real time, but you do have Facebook referrals, that's a very good proxy to use. So we have the yields, and of course with a personalized content recommendation system, so we had to combine that with the affinity of the user to different characteristics of the document that we're trying to rank. So this is basically a model of models. We're applying all sorts of metrics to indicate the proximity of the user to the document. It includes the user to articles Jacquard similarity in terms of the article's LDA category. We have 2 sets of categorizations. One is based on LDA, one is based on a logic regression. We also have the affinity of the user to visit the publisher and the specific section on the publisher. And currently a work in progress is also to include a matrix factorization score of the affinity of the user to that article. But this group is basically the personalization score of how much the user might like that article, regardless of the behavior of the crowd. And finally, we interact all of these yields. So once you have a model and you have the data, you need some estimation methodology. Now note that for different users, you might have different levels of confidence. So if one user, I have the history of only 5 page views and maybe 1 share. And for a different user, I have the history of 100 page views. So I'm quite confident in what the second user likes, but I'm not so confident in what the first user likes. So that's the level of confidence in the profile of the user. In addition, there is also the level of confidence in the yields, right? If you have a CTR based on 1,000 impressions, it's not the same as a CTR based on 1 million impressions. So we needed some methodology, some estimation methodology that can bucket different signals into different levels of confidence. We used a machine learning framework developed in-house in Outbrain. It was developed by Ronnie Lempel, Ilan Orlov, and Danny Rosenstein in a paper that is upcoming this year. And this methodology basically allows you to bucket the signals, any signal that you would like, into confidence buckets. And every signal is allocated into one specific confidence bucket, and you have missing values in all the rest of them. This also deals with some documents not having signals about shares. So maybe we couldn't access the API of Facebook in order to get the shares, or it still didn't have any referrals because no one has shared it anymore. So basically, it assigns missing values to all the signals that every user times document doesn't have. And in that matrix, it runs it with gradient descent in order to estimate all the coefficients, ignoring those missing values. Finally, when you have a user that you need to rank and you have some missing values to some users and some documents, then you can assign a weight for every signal that you do have based on the sum of all the signals that you have. And finally, we've estimated that model and we could deploy it in production. We've A/B tested a model that compares the previous recommendation system of Sphere that utilized mostly popularity signals and personalization signals to the new recommendation system that utilize both page views, CTRs, and Facebook referrals. We saw that there is a substantial lift in CTR in production in the A/B test that we've utilized. So combining, the conclusion from here is that combining different signals, combining also different models can generate a substantial lift, and the methodology for estimating such a model is described in the previous slide. Finally, we wanted to see which one of the metrics that we proposed had gained the most important, the largest lift to precision. So each time what we did was to estimate the model including all three signals, then we've extracted one of them, including all the interactions that it had with all the other signals. And we've ranked the different signals, engaged CTR, pages, and Facebook referrals, as which one of them contributes the most. What we obtained, and this was very robust across different applications across Sphere, was that utilizing the engaged CTR, what people click at the bottom of articles, was had the largest contribution to predictive ability. Second was Facebook referrals. So it's not that it's such a bad signal. It's just, it's not as good as looking at CTRs at Outbrain. And finally, the most biased one, the signal which contributes least was page views. So if you have to think about which signals to utilize, first our conclusion is that you should try to combine as many as possible, because each one of them captures something else. But if you can utilize something, try looking at CTR. So in conclusion, I've shown you three things. I've shown you an argument that says that what people read about is not what they shared. We showed that crunching a lot of data can prove that there is a substantial difference between what people share and what they read. We saw it across categories. We've seen that categories that to the human eye might seem quite perhaps shameful to say that you're reading is something that people are not very likely to share. And finally, we've deployed a recommendation system that actually utilizes all three signals, combining with personalization scores, and gains substantial lift in CTRs. And finally, when sharing one personal experience, this paper was accepted recently to WWW conference. And when we got accepted, I was so excited I wanted to share it on Facebook, and I couldn't but help but realize that this was quite ironic that I'm sharing something like this. So thank you very much.